Good morning, class. Hope you're doing well. So today our lesson is going to be about electricity at home. And pardon the pun, the cost may shock you. So we are going to be looking at the practical part of electricity, so the practical aspects of the cost and conservation and electrical safety today in this lesson. We've covered a lot about the fundamentals of electricity, so now we want to move on to the more practical aspects. Okay, so for example, how does the electrical company know how much money you use, how much energy you use, and how do they calculate the cost of that energy that is used by different households, and how energy can be conserved, and how you as your parents and yourselves, how can you reduce the cost of the energy that is consumed, and how to avoid potential hazards when using electrical devices. So, the key question: what happens to electricity once it reaches your home? Learning goals: describe what happens to electricity once it reaches your home, identify and describe electrical safety features, and then finally calculating the costs of using electricity. So safety, so there's a number of different features and I guess technologies that exist in order for you to safely use electricity within your homes. And two of these technologies you've seen, I'm sure you guys have seen, maybe if not in your own homes, but you've definitely seen these in textbooks or in on TV. So the first one right here is what are known, these are called fuses. And this is an older type of technology. And basically it is a control device to use to control the flow of electricity as it is distributed coming from the transformer from the electrical supply company. The electricity comes through what is known as a transformer, basically something that converts the electricity that is has very, very, very high potential energy, so very high voltage, and reduces it to a more a reduced amount and a safer amount as it enters into your homes through those power lines. And this is basically what is known as a circuit breaker. And this is or a breaker panel, which acts like a fuse as well. And basically it will this panel, the circuit breaker, will act pretty much the same way as these fuses. And when you have too much electricity coming into these fuses, basically they burn out, because you don't want to have too much current coming through the electrical wiring in your house. So when that happens, these are designed to basically break that circuit. And hence the term circuit breakers. These are safety devices meant to reduce the likelihood of fires happening because of high currents. And you've probably seen the circuit breakers in your homes. And basically when there is a fuse that happens within the kitchen, there's too many electrical appliances being used at the same time, too much current is being drawn, and the fuse basically goes off, and you have to go downstairs into the basement. Usually these are located in the basement of most homes. And you basically, with this circuit breaker, you flip a switch, and this causes the circuit to start to function effectively again. It basically closes the circuit, okay, whereas before the fuse is what breaks the circuit when too much current is going through. So both devices open when too much current flows through. Circuit breakers can be reset by switching right over here, basically by just pushing a button or a lever to the opposite side, okay? And these are the old fuses. There's fuse boxes that contain these, like they look like little mini light bulbs, which basically can be done as well. And then you have what is known as a ground fault circuit interrupter, GFCI, and these are basically their outlets that trip. They open the circuit when a difference in current is detected between the hot slot and the neutral slot, okay? So these types of these GFCIs, they're found within the bathrooms, and they usually are, they're not found everywhere. They're mostly found in bathrooms where there's more of a potential hazard for a fire or shock, electric shock to happen because of water. GFCIs must be installed when an outlet is near water. Okay, and then there's also these things called surge protectors. These prevent damage to electronics caused by spikes in voltage. So when the surge protector detects a spike in voltage, it diverts it to the ground. Okay, there's a connection to the ground right over here, this prong right here. Electricity can go right into the ground when there's too much, and there's a spike in the voltage. That extra can go into the ground. Okay, so conserving electricity. There's a number of different things that we can do, but these are just some examples of, I'm sure your parents have told you this many times because, you know, they're the ones that are paying those electricity bills in your home. So turning off the lights when we leave the room, using energy efficient appliances, and we'll talk about that later on, because there are appliances that are much more energy efficient than the newer ones are more energy efficient than the older ones, and using energy efficient lighting as well, that makes a huge difference in terms of being able to conserve electricity. Turning off power bars when you're not using those electrical devices. Turning up the thermostat in the summer. So like, you know, sometimes we go into some houses or some buildings where in the summer the temperature is not, it's actually uncomfortably too cold. In my opinion, sometimes you go to the mall or you go to a restaurant and the air conditioning is blasting, and it's, you know, it's completely the opposite of when we are, you know, in our homes in the winter. We want to feel comfortable. By turning the thermostat up a little bit, you're still comfortable, but you don't, you know, you're saving electricity, but you know, there's no need to feel like cold or a chill in the summer. Putting your computer to sleep when you're not using it, and then unplugging chargers also when they are not in use. So anything that you can unplug, that really helps in conserving electricity. Because of this term, phantom load, these are devices that even when they're turned off, when there's a switch to turn them off, they still consume a little bit of energy, because of the fact that they use, like, for example, an alarm clock, devices like TVs, alarm clocks, DVD, Blu-ray players, game consoles, they have a standby mode, and basically this mode uses not a lot of power, but even a little bit of power, even when they're turned off. Like a remote control, for example, that red light shows that it's kind of always on. So it's obviously using it's using electrical energy, even when we're not actually, when we don't have the TV on. Phone chargers use energy whenever they are plugged in, even if the phone is fully charged and not even connected. So anything that you've got into an electrical socket has the potential, if it's still connected to your phone or to a TV, for example, if it can be still using a minimum amount of electrical energy. So measuring consumption. How does the electricity company know how much energy you're using in your home? Well, when electricity reaches your home, the first step is it travels through what is known as a smart meter. Okay, and this basically is a device that measures your electricity usage hour by hour, and the smart meters are where they are automatically connected to the electrical company, and the electrical company, and the person does not have to come from the electrical company and go to the side of your house to measure the readings from your electricity meter. Smart meters are automatic, and they basically measure the electricity usage hour by hour and send that information to the electric company. So measuring consumption. Devices use electrical energy at different rates, and this is known as electrical power. So electrical power is measured in what is known as watts. Okay, and this capital W is the symbol used to represent the word watts. And we talk about kilowatts a lot of the time when we're trying to figure out cost of electricity. So basically, there is 1 kilowatt is the unit of power that represents unit of power that represents 1,000 watts. So a kilowatt hour is the amount of energy transmitted by 1,000 watts of power over a period of 1 hour. Okay. So for electrical power is measured in kilowatts for large appliances. And in order to calculate the cost, there's a few things that need to be taken into consideration. And these two factors include the energy that is used, okay, which is kilowatt hours, and then the rate, which is basically the cost, how many dollars per kilowatt hour that the electricity costs. And this varies from within Canada, from province to province, and even within Ontario, this rate varies from weekday to weekend, and from different times of the 24-hour day. Like on a weekday, it's a lot more expensive to use your electrical loads during the day compared to in the evening after 7, for example. Like your dishwasher, people usually put on their dishwasher and their laundry machines in the evening, their dryers in the evening, because the rates are very they're so much lower than during the day. So the formula to calculate the cost is basically very simple. It's the energy that is used in kilowatt hours multiplied by the electricity rate. Okay. Oops. So let's do an example. So a dishwasher has a power rating of 1,800 watts. If it is used for 90 minutes and the cost of electricity is 13 cents per kilowatt hour, what is the total cost of running the dishwasher? So we've been given some information. We've been given the power rating, which is 1800 watts, and we've been given the time, which is 90 minutes. So we can calculate the power. And then we've also been given the rate, which is 13 cents per kilowatt hour. And the question is, what's the total cost of running that dishwasher for the 90 minutes? So first we need to do is because we need to the rate is kilowatt hours. So we've been given 1800 watts. We need to convert the watts into kilowatts. Okay, so we do that by dividing 1800 watts divided by 1000, so it's 1.8 kilowatts. Okay, and then we've got kilowatt hours, so we need to convert this into hours as well. Okay, 90 minutes into hours, and that you don't always have to do that, but in this case we do. We basically divide 90 minutes divided by 60 is 1.5 hours. So basically 90 minutes, okay, is basically 1 hour. You can just convert it. You get rid of, so 90 basically divided, 90 divided by 60, you get the 1.5 hour, okay? And then you calculate the energy used by multiplying the power rating, which is 1.8 kilowatts, by the time in hours, 1.5 hours. And this is your the energy used. Okay, and then we have to multiply that number, 2.7 kilowatt hours, by the rate, which is 13 cents. Okay, and so when you do that calculation, you get basically 35 cents. So remember, with the GRASS method, let me just write that over here because a lot of you were not using this. This is given, required, analysis, solution, and statement. Okay, so this is the last part of your problem. You would include a statement. So it would cost 35 cents to run the dishwasher for 90 minutes, and that's how you would calculate that problem. Okay, now efficiency is another type of calculation that we could use to find out how much useful energy a device produces compared to how much energy the device used. Okay, so there are some electrical devices that they are, for example, a light bulb is the work that a light bulb does is it's supposed to provide light. So that electrical energy that is coming into the light bulb is converted, or it should be converted, into light energy. But a lot of that energy is not converted into light energy, and it's basically given off as heat energy, which is a wasteful energy in that example. So efficiency measures how much of the useful energy a device produces compared to how much the energy the energy the device used. So one device is more efficient than another if it accomplishes the same task using less electricity. So in Canada, every household appliance is sold with what is known as an EnerGuide label. And basically this EnerGuide label gives details on how much energy that appliance will use in a normal year of normal consumption in the year. So this is an example of an EnerGuide label. This is what you see on, when you bring in a fridge or a dryer or a stove, a dishwasher. They all come with this kind of label on which is very visible. It's quite a large label, and there's this information. So this is basically, it tells you that it uses 554 kilowatt hours per year. So that's like the consumption. So comparing it to similar models, this is where it stands. Okay, there are some models that use a lot more, and some models that will use even less than this particular device. But it just shows you in comparison to other types of, let's say it's a dishwasher, this is where it stands right here in terms of energy consumption within within a year of normal use. Okay, not excessive use, not underuse, but normal use. So efficiency in terms of light bulbs. Some light bulbs are more efficient than others. Okay, you can look at these. For example, this is a 60-watt incandescent. These are the kind of the older the light bulbs that most people used to use. And you can see that the energy usage for a incandescent light bulb is 60 watts compared to 14 watts and only 12 watts in a LED light bulb. Okay. The brightness is pretty much the same for all of the light bulbs, but you can see that the LED will last 50,000 hours compared to 10,000 hours of the CFL light bulb, and only 750 hours using this incandescent light bulb. So, and then yearly operating cost is $12.92, $3.01, and $2.58. So looking at it, this light bulb is going to be the most efficient. It lasts the longest. It uses the least amount of energy, 12 watts compared to 60 and 14, and it's just as bright. Okay, and even there's like $200 of lifetime savings over an incandescent bulb with the same brightness. So this is just showing you the difference in terms of efficiency, electrical energy efficiency, comparing those three different types of light bulbs. So you can also calculate percent efficiency of different appliances. So energy, again, is measured in joules. We've talked about this before. So a joule is equivalent to 1 watt operating for 1 second. Okay, so 1 joule is equal to 1 watt second. Okay, so the formula used to calculate percent efficiency is percent efficiency is equal to the useful energy output divided by total energy output multiplied by 100%. Okay, so where the useful energy input is the amount of energy, non-electrical, that a load appliance produces. And the total energy input is the amount of electrical energy that a load uses. So this is produces, the top part, and this is basically how much the load uses. So we can do this, another example. So Sarah boiled a cup of water in her kettle. The energy required to boil water is 168 kilojoules. The kettle has a power rating of 1500 watts, and it took 2.5 minutes to boil. Okay. Calculating the efficiency. So we have to do some conversions because 1500 watts, we need to convert that into kilowatts. And so we just divide that by 1,000. We've done that before. So the power rating is 1.5 kilowatts. And we're converting the minutes into seconds because we wanted to remember this is, where is it? 1 joule is equal to 1 watt second. Let me go back. So 2.5 minutes multiplied by 60 is equal to 150 seconds. And then we calculate the energy used by multiplying the power rating and time. So this is the power rating, which is 1.5 kilowatts, by the time, 150 seconds, which is 225 kilowatt seconds, or it's also kilojoules. It's the same, means the same thing. And calculate the percent efficiency using that formula that was given. So useful energy output, okay, divided by the total energy input, which is 225 kilojoules, and multiply that by 100%, it's 74.67%. And the concluding statement would be the kettle is 74.67% efficient. So this basically is 2.5 minutes converted into seconds. Okay, just in case you didn't realize what I was doing there. Oops. Okay. So you were given some problems. I'm gonna add some problems for you to work on in the Google Classroom along with this lesson. Please make sure that if you don't understand something, if you have any questions, please let me know, and I will help you as much as I can. Take care, and I'll talk to you soon. I don't know where the screen is gone. Oh my goodness. I don't know where my